So obviously starting a new unit, looking at rational functions. Let's talk about exactly what that means, because that may just be two kind of mathy words in your head that doesn't make any sense to you. Okay, so right underneath that, first thing it says is, what is a rational expression? So the word rational, what's kind of the foundational word within the word rational? Ratio. Okay. Ratio is a fancy word for what? Do what? A fraction. So a rational function is just a fraction comprised of two equations. Okay, you see them all over. You see examples all over that half sheet right there. So how you might say that, or kind of the way that I want you to write that in there. We're going to stick with ratios, but okay, ratios with polynomials. Okay, remember polynomials is just really any kind of algebraic expression, any kind of equation. So these first two problems, these are just basic fractions, and we're gonna simplify these today. All we're gonna look at is simplifying. Next class we'll talk about multiplying and dividing, and then we'll talk about adding and subtracting the one after that. But right now we need to know how to simplify before we do either one of those. So we're going to simplify these fractions, and I get it. Most of you can hopefully tell me, that 3 over 6 is 1/2. Okay, hopefully you know how to do that. I'm going to do this in a way that's going to be more applicable to the process that we'll have to do here. Okay. So if I have this, I'm going to break down 3 into its factors, okay, which is 3 and 1. And so I could break down 6 into what two factors? Okay, 3 and 2. Okay, and then now I need to look to cancel something. I can eliminate the 3's, which is going to give me 1/2. Alright, so 8. Greta, I could break down 8 into what two factors?
2 and 4 and 1.
Wow, Greta, your voice has changed over the break. It's much deeper now. What did you say there, Connor?
8 and 1 and 2 and 4.
Okay, let's do 2 and 4. Okay, so if I do 2 and 4, now, Greta Kennedy, I can break 24 down into what two factors? Okay, I can do 6 and 4. Does anything cancel? The 4's. So now I've got 2 and 6. Alright, 2 is a prime number, so I can just break that down into 2 and 1. And then I can break 6 down into what? 3 and 2. My 2's cancel. And so we've simplified that down to 1/3. So the steps up in the top right, we're going to go through those, and I'll stop whenever we talked about the restricted values. But looking at number 1, first thing I need to do is to factor. So what term am I missing on number 1? C value. So that means all I have to do is what? Greatest common factor. Gavin, what is the greatest common factor in the numerator?
X.
Just x. So I'm going to pull an x out. Rachel, the denominator?
X.
Okay. So with those restricted values, kind of what that's talking about. So the thing about fractions. What is the only number that denominator cannot be? If you have a fraction. It can be 1. 0. You can't divide anything by 0. Okay, you put that in the calculator, you try to do that, you're going to get undefined. Okay, so your restricted values, those are the values of x that would make that denominator 0. Okay, so somewhere kind of off to the side, I wouldn't put this right in the middle of this problem. We're going to write how you find the restricted values. And it is not very difficult at all. To find those, you're going to set each factor in the denominator. That's something a lot of people will struggle with because they'll try to do every factor within the whole problem. You're just looking at the denominator because that's the thing that can't be 0. So you're going to set each factor in the denominator equal to 0 and solve. So it's just like whenever we would factor a quadratic equation, we're trying to find the roots. You know, it's this stuff. I kind of referred to it earlier. It's this stuff, but then it's taking your factors and setting them equal to 0 and solving those. So on problem number 1, what are my 2 factors? What are the 2 pieces that I broke off in the denominator?
X
Not x and 5. X is 1. What's the other one?
X plus 5.
X plus 5. It has to be all of that. Okay, so those are the 2 pieces. So I'm going to take both of those. I'm going to set x equal to 0. Well, I don't have to do any math. That's solved for. Oh. Okay, so I set that x equal to 0, and then I'm going to set the x plus 5 equal to 0. And I'll solve, and I'll get negative 5. So my restricted values on this, x cannot equal 0 and negative 5. Alright, sometimes you'll have 1 restricted value, you could have 3 restricted values. Okay, there's not a set number of restricted values you can or cannot have on these problems. So what these are, and again, kind of what these are for, those are the x values that would make that denominator 0. When these come into play, and they will a little bit later in this unit, is if I'm having to solve a problem, I may have multiple answers. So if I have 3 answers and it's 10, 7, and negative 5, well, my restricted values say I don't need to include negative 5 in my answers because x cannot be negative 5. Okay? David, you have a question? Alright, so up there in that box in your notes, we listed the restricted values. Next it says to cancel common factors. So looking back up at x times x plus 3, x times x plus 5, does anything cancel up there?
What would be the x?
The x's cancel. And so my answer on this is x plus 3 and x plus 5. That is the answer. You'll need to do that and then include your restricted values. You'll always need to identify those.
Which we already did.
Yes. Alright, so looking at 2. We already did 9x plus 3. We already factored that in the warm-up. Okay, so that one's easy. All I got to do is pull a 3 out of that. In the denominator, what is my greatest common factor there? So after that, I need to find my restricted values. And this is a part that some people struggle with because what are the 2 factors that I got from 12x plus 4? 4 and 3x plus 1. So I know I'm going to set the 3x plus 1 equal to 0. I would subtract 1, divide by 3. So negative 1/3 is going to be 1. But 4 is not going to give me a restricted value. Only the factors that have x in them is going to give you a restricted value. Because if I set 4 equal to 0, and I try to solve for x, well, there's no x to solve for. Okay? So on this one, my only restricted value is going to be negative 1/3. Alright, and then Jeremiah, does anything cancel out up in the problem? The 3x plus 1s. So my answer on this would be 3/4. So next, we're going to actually skip number 4. We'll come back to it. I think it's kind of tricky. No, we'll do it last, actually. So let's go to 5. So, can I factor the numerator? No. And the denominator looks familiar. What two factors is the denominator going to give me? X minus 5 times x minus 5. So I'm going to end up with this right here. And guys, you're probably going to find that on some of this stuff, on worksheets, on maybe even the quizzes or tests, where you may have the exact same equation that you need to factor. Well, don't use the work that you've already done to speed up the process. We've already factored that. Okay, so on this problem, what would my restricted value be? Positive 5. Do I need to write it twice? Just once. Okay. Does anything cancel? Yes. Do both x minus 5s in the denominator cancel? No. We can only cancel out one of them. So on the bottom, I'm left with x minus 5. I canceled everything out on the top, so what do I need to write up there? Not 0. 1. If everything cancels, you're going to write 1 up there. Going down to number 6. What two factors is x squared minus 9 going to give me? It's one of those situations we saw in the warm-up. X minus 3, x plus 3. Okay, the denominator, I've got all three terms. So I can do the pyramid. So I've got 1 times negative 27. What factors of negative 27 add up to positive 6? What are some factors of 27? Okay, 9 and 3. So, if it's negative 27, one has to be positive.
Negative 9 and positive 3.
No. Switch those. So, positive 9
Negative 3.
and negative 3. 9 minus 3 is going to be positive 6. Okay, so, Helene, what are my two restricted values going to be on this problem? 3 and negative 9. Alvin, does anything cancel in the problem?
The x minus 3s.
The x minus 3s. So I end up with x plus 3 over x plus 9. again, I look at this, I see that denominator. That looks very familiar. Have we already factored that? Is that not the only one that looks familiar to?
Factor the bottom
Yeah, that's what I was saying, the denominator.
one.
Okay. What did we get whenever we factored that?
X plus 3 and 2x minus 1.
Awesome. Okay, the numerator. What do I need to do first? Greatest common factor. Just because I have all three terms, okay, don't just automatically do the pyramid. You always need to look for that. And after this first step, I'll explain the benefit of that. So if I can divide 3, 3, and negative 18 all by 3. And then now I would want to do the pyramid. So whenever I do that, now I'm finding the factors of negative 6 that add up to 1, which isn't very difficult, as opposed to if I hadn't have done that, now I'm trying to find the factors of negative 54 that add up to 3. Okay, one is obviously easier than the other. What factors of negative 6 add up to positive 1?
How are you getting negative 6?
1 times this one right here in front of x squared times the negative 6. Once I pull out a greatest common factor, I'll ignore that in the pyramid in the next factoring part. So what factors of negative 6 add up to positive 1? Negative 2 and positive 3. Okay. Now, real quick, do I still need to write this 3 in front? Yes. Okay. Because remember, over here, this is, here's my big, awesome castle that I made out of Legos, 3x squared plus 3x minus 18. Okay. If I'm breaking it down into the pieces, and I want to rebuild it, I still need this 3 to get back to this. I still have to include it. Okay, this is all the pieces I need to build that. So now that I'm here, okay, I've got it factored down all the way. Jeremiah, what is one of my restricted values? Negative 3. Alvin, what's the other one? 1/2. All right. Alessandra, looking at the problem. Back down here, does anything cancel out? X plus 3. So I'm left with 3 times x minus 2 over 2x minus 1. There's the answer. So looking at that, and the reason why 4 is weird is because the numerator has one term. Okay, so it's kind of hard to factor that, and I can factor that many different ways. I could do 2 times 5 times x times x times x. I could do 10 times 1 times x times x times x. There's a lot of different ways I could do that. I'm going to go to the bottom, and I'm going to factor that because there's really only one way I can factor the denominator. And what would I need to do? Greatest common factor, which would be what? 2x. So I've got 2x times x minus 9. Now, whenever I do that, I kind of have an idea, and as you can tell, on all these problems, we eliminated something. If you can eliminate it, then you need to. That's the simplifying process. So, if I have these two factors, I kind of have an idea as to what I'm trying to get in the numerator. So, can I factor out an x minus 9 from 10x cubed? No, okay, because it's x. I can't factor out a binomial from a single term. Can I factor 2x out of 10x cubed? Yes. Okay, so it's going to be 2x times what? 5 x squared. All right, David, what is my two restricted values here?
2 and
9 and not 2. Nope. And these are one of those things that a lot of people, it's one of those deals where it's so easy, it makes it difficult. If I set it equal to 0, no matter what that 2 is, whether it's 2 or if it's 8 or if it's 10 or if it's negative 1/3, whatever, okay, I'm going to end up dividing 0 by that, which is always going to give me 0. So if you have one of those single term factors down there in your denominator and it has to have x in it, that's going to always give you a restricted value of 0. Okay? And so now looking at the problem, does anything cancel? 2x. And so I'm left with 5x squared over x minus 9.